welcome to today's class. For today's class, we're discussing the vector or the cross product of two vectors. Let's say I'm given the vector A as being equal to AXI plus AYJ plus AZJ, and I'm given B as being equal to BXI plus BYG plus BZK. So I have A and B. Let's look at their cross product is given by A cross B like this. Let's derive the formula for the cross product of two vectors. Before we derive this formula, let's get something. Now here's your cake. Here's a cake. So first of all, we have something like a circle, like this. Divide this into three parts. Part 1, part 2, and then part 3. So we have this. Perhaps I want to make them clockwise direction. So I have this one there, this one there, and this one there. Call this I, call this J, call this K. Now, you guys want to note that for cross product, I cross J is equal to, so I and J goes in the same direction. It gives you K. That's K. Next up, J, starting from here, J cross K leads to I. So that means J cross K leads to I. Also, starting from K, K cross I leads to J. So K cross I leads to J. Let's not do it anti-clockwise. So we did it this and this and this. Let's do anti-clockwise. If I go reverse direction, it becomes I cross K equal to not just J but minus J, because I'm going in the reverse direction. So that means that I cross K is equal to minus J. So that's this way. I cross K, reverse direction, minus K, minus J. Next up, carry K. So K cross J is minus I because it's opposite direction. So K cross J is equal to minus I. Finally, J cross I equal to minus K. J cross I equal to minus K. In this case, I dot I is, or I cross I is equal to 0. J cross J is equal to 0. K cross K equal to 0. So please note this identity. We use them in deriving our formula. Alright, so having said that, let's look at A cross B. So A cross B, A cross B would be equal to A is AXI plus AYJ plus AZK. So that's A cross. Next up, B is BXI plus BYJ plus BZK. So I have this. Alright, from this now, if I multiply through, starting with AX, I'm having AX, BX, I cross I. So AX, BX, I cross I plus, use AX to, okay, yeah, AX to BY. So AX, BY, I cross J. AX, BY, I cross J. Plus, finally, AX, BZ, I cross K. AX, BZ, I cross K. I cross K. I'm done with this. Let's start with B. Let's take AY plus AY BX. I have J cross I plus use AY to BY, BY, J cross J plus BZ, J cross K. So I have this. I'm done with AY. Let's now use finally AZ. So plus AZ dx into K cross I plus AZ by K cross J, finally plus BZ K cross K, so we have this. If I substitute values, I have AX dx, so AX dx, I cross I, we said is 0. That gives you 0 plus AX dy, I cross j, we said I cross j is plus k, so I have plus k or k plus AX BZ, we have I cross k, we said I cross k is minus j. So having minus j plus I have AY BX into J cross I. J cross I is minus K. So that's minus K plus AY BY, J cross J, we said 0. Plus finally AYBZ, we have J cross K. J cross K is equal to plus I, so plus I. Next up, AZBX plus AZBX. I have K cross I. K cross I is plus J, so plus J plus I have AZBY into K cross J. K cross J is minus I, so I have minus I, and then plus finally AZBZ, that's equal to K cross K, which we said is equal to 0. So we have all of these parameters. That means this one cancels out to give you 0. This times 0 is off. AYBY times 0, that's 0, is off. AZBZ, that's 0, times 0, that's 0, is off. Alright, so if you're done from here, I will take the ones having i's first. Positive I, negative I. That's this one first. This one has positive I, this has negative I. So it becomes AYBZ. So that's equal to AYBZ into plus I. Take the next I, which is minus I. That's AZBY. So plus AZBY to minus I. Take plus J. So I'm taking them with I, J, and K. Alright, so take plus J. Plus J is this one, yeah? AZBX. So plus AZBX. That's plus j plus get minus j. This one ax bz. So ax bz minus j plus take plus k. Plus k is this one here, ax by. So plus ax by, that's plus k plus get the minus k. Minus k is this one here, ay dx. So ay bx into minus k. Alright, for this now, we'll now factorize them. That's equal to, I have I, so under I, of course, positive I times this is ay bz plus minus is minus az by. At this point, we factorize, okay? So this times I, the I comes here, so positive I to this is negative, minus plus comes here, so I times this gives you this I, my I times minus this gives you this minus I, same thing, just factorization. Plus, same thing here for j, take the j outside, becomes j into, I'm having here as az bx, I'm having minus with this, so I'm leaving the minus with this, so minus ax bz, I have it. Finally, plus k, so plus k into the same thing here, I'm having ax by minus this here, minus ay bx. So this becomes the formula for cross product of two vectors. But one more thing, usually for this case, this is equal to I into ay bz minus az by. For this one here, we want to make this j to be negative. To make j negative, it means this negative here, or perhaps take here as minus. Minus multiplies here, makes it minus here. This minus comes to minus, makes it plus. So we take the plus before the minus, it becomes minus j into this one here. Ax bz minus az bx. Why this one is correct? We are doing this just for a purpose, which I will show you much more later. But observe the way I change that to minus. I multiplied it by minus. It became minus j. The minus comes here, minus this. The minus to the minus I added became plus. So I took the plus first before the minus. So it's just a simple mathematical approach to that. Plus k into ax by minus ay dx. So I have this. So this becomes the formula using cross product. Now this thing looks very long. So look at a much more shorter approach to this formula using what's called determinant of a matrix. So let's look at a shorter method of getting this formula without the whole long process. Now, get shorter method. If I have A cross B, it can be expressed in matrix form as being equal to I, J, K. I had AXI, AYJ, and AZK. BXI, BYJ, and BZK. So I had this. Of course, this looks like a 3 by 3 matrix. I will use the idea of determinant of the matrix, which is said is what? Plus, minus, plus. So that's equal to plus I into, so for I, you cover the row here and the column. For I, cover here, row, and cover here. It gives you A1, A2, AY, BZ. That's this. So having A1, AZ, okay? minus plus is a constant. It's always like that for any 3 by 3 matrix. Alright, so plus I. So plus I into cover the row of I, which is here, cover all the here, the row of I, cover here, which is this, cover the column of I, which is this, so cover here and cover here. I'm left with A1, AZ, BY, BZ. So A1, AZ, BY, BZ. Next one, minus J. So minus J into, for J now, cover the row, that's covered here, cover the column, that's covered here. I'm left with AX, AZ, BX, BZ. That's AX, AZ, BX, BZ. Finally, plus K. So plus K, cover the row, that's here, cover the column. That's AX, AY, AX, AY, BX, AY, BX, BY. So we have this, right? That's this. To solve this one, that's equal to plus I into, for this, we said elements in principal diagonal will multiply. So the one by your right, this 2, that gives you AY, BZ minus these 2, AZ, BY minus J. So minus J into this and this, AX, BZ minus AZ, BX, AZ, BX plus K into AX, BY, AX, BY minus this and this, AY, BX. So this now becomes the formula. If you look at this and this are the same thing. So this is like a short form of deriving the formula using determinant of a matrix method. Perhaps now you now see why we change the J to minus so that to match this, as you can see. Right, so it matches this AX, BZ minus AZ, BX. So this is why we had to change this to minus. But if you do this as plus as before, it's still correct. Alright? So this is the formula for the the vector or cross product of 2 vectors. One last thing, we can still express vector product as this. We can still say A plus B is equal to magnitude of A multiplying magnitude of B and then sine theta. This can be used to find the angle between 2 vectors. We have this. So we have this case here. So let's take one example. On cross product. So given that a vector A is equal to 2i plus 3j plus 4k. And B is equal to I minus 2j plus 5k. Find A plus B and the angle and theta, which is the angle between A and B. Alright, let's get this done. Solution for this one. I'm given A plus B. This is now cross product, and for cross product, you express it in terms of matrix or as the determinant of a matrix. That would now be I, J, K. This is 2 under I. This is 3 under J. This is 4 under K. This is 1, yeah, coefficient. This is minus 2. This is 5. So I have this. If I work this out, this will be equal to, I'm having plus, minus, plus. So I have plus I into cover the row, cover the column. 3, 4, minus 2, 5. 3, 4, minus 2, 5. Next up is minus j. Minus j into cover the row, yeah, and the column. I have 2, 4, 1, 5. So I have 2, 4, 1, 5. Next up, plus k. For k, cover column and row. You have 2, 3, 1, minus 2. You have 2, 3, 1, minus 2. So this is now equal to I into 3 times 5 is 50. So it becomes 3 times 5 minus 4 times minus 2. 4 times minus 2 minus j into 2 times 5. 2 times 5 minus 4 times 1. 4 times 1 plus k. That's this into this times this. This times this. 2 times minus 2 minus 3 times 1. 3 times 1. So I have this. From this, I'm having equal to I into 3 times 5 is 15. Minus 4 times minus 2 gives you plus 8. Minus j into 2 times 5 is 10. Minus 4 times 1 is 4. Plus k into 2 times minus 2 is minus 4. Minus 3 times 1 is 3. So I have this. So this is now equal to I into, if I add these two, this gives 23. Minus j into 10 minus 4 is 6. Plus k into minus 4 minus 3 is minus 7. This is equal to 23i, this and this, minus 6j, minus plus, minus 7k. So this becomes the value of their cross product. So a plus b is equal to 23i minus 6j minus 7k. Now, what you should note is this. When it comes to cross product, your final answer is in vector form, as you can see here. Unlike what we did when it comes to cross product, unlike what we did with dot product, in dot product, your final answer will be just one, what's it called? Just one number. That's it. Alright, so this can become the cross product. In case you're asked to find the magnitude of the cross product. So the magnitude of the cross product becomes the magnitude of A plus B, and that's equal to the square root of each of these terms squared, 23 squared, plus minus 6 all squared, plus minus 7 all squared. I have this. Let's punch this. This is equal to square root of 23 squared is 529 plus minus 6 squared means minus 6 times minus 6, which is 36, plus minus 7 squared means minus 7 times minus 7, which is plus 49. So hence, this is equal to the square root of 529 plus 36 plus 49. This is 614. Okay, and that's equal to 24.78 to 2 decimal places. So this has to get the magnitude of A plus B. So if you have to find A plus B, this is the value. If you have to find the magnitude of A plus B, then you do this and get this answer. So this is how to get the magnitude of A plus B. But of course, to do the angle, for the angle we said A plus B is equal to magnitude of A times magnitude of b and then sine theta. If I make theta substitute the formula, theta will be equal to sine inverse of a plus b all over magnitude of a into magnitude of b. So very quick, let's get these two. Magnitude of a is equal to the square root of, for a I have what there? 2 squared times 3 squared times 4 squared. So 2 squared times 3 squared, so plus 3 squared plus 4 squared. That's equal to square root of 2 squared is 4. I'm getting final answer. So 2 squared plus 3 squared plus 4 squared. That's root 29. Okay. Magnitude of b is equal to the square root of, for b I have 1 squared plus minus 2 all squared plus 5 squared. So plus 5 squared. This will give a final answer of, this is 1, this is 25, this is 4, that's 29 plus 1, that's 30. Alright. So therefore, theta is equal to sine inverse of, we said sine inverse of a cross b. I'll be using the magnitude value, which is this. A cross b in magnitude is 24.78 all over. Magnitude of a is root 29 times root 30. So root 29 times root 30. So theta is equal to sine inverse. Punch all of this with the calculator. I have 24.78 all over root 29 times root 30, and that gives 0.84. Take sine inverse. Theta is equal to sine inverse of 0.84. That's 57.14 degrees. So this becomes the angle between the two vectors. So this is how you solve this problem. Right, one last thing please. Note this. Note, if two vectors are parallel, it means that their cross product is equal to 0. Now, here's your proof. A plus B is equal to magnitude of A, magnitude of B, and then sine theta. If two things are parallel, like this, two parallel lines, they cannot meet. So hence, the angle between two parallel lines is equal to 0. So for parallelism, or if they are parallel, we have that theta is equal to 0. So now have that A plus B is equal to A dot B into sine 0. Sine 0 is equal to 0. So now have that A plus B is equal to, so this one gives you 0. So all of these times 0 gives you 0. So please take note. If they say two vectors are parallel, it means that their vector product or cross product equal to 0. As we said in previous class, if they said two vectors are perpendicular, it means that their dot product for perpendicular, it means that their dot product A dot B is equal to 0. Alright, so that's as much as we can take for today for vector product or scalar or cross product of vectors.